thank you very much for joining us on this, our second pre-COP26 webinar. Our series is called For Nature's Sake, where our webinar last week was about what we wanted from COP26, and this one we're going to be unpacking the relationship between nature and carbon. You've no doubt heard a lot about it, but this is an opportunity to dig into some detail with some real Sussex leaders in the topic. So what I've got a slight warning, we have promoted this as being a 1 hour session. I think realistically it's probably going to be 1 hour and 10 minutes. So my apologies for that, because there's a lot to say, and we're hoping at the end we can take some questions. So do put your questions in the Q&A. Obviously, we're not going to be able to answer everything at all, but we hope all our panelists will join us for answering questions at the end of the session. So first of all, I'm very pleased to welcome Matthew Bird, who's the Climate Action Lead at the Sussex Wildlife Trust, who's going to start off by telling us about the work that Sussex Wildlife Trust has been doing around carbon and nature.
Hello everyone, I'm just going to attempt to share my screen, and hopefully you can see that, although there we go. So yeah, I'm just going to do a quick canter through the work that we're doing as a trust on carbon reduction, and firstly, I just thought I'd say a little bit about COP26, you know, why we are here. As you probably know, it's the climate conference, global climate conference of parties. So this is where essentially 196 nations are seeking firm action, commitment to deliver the agreements that were made at the Paris climate talks in 2015. And the main thrust of that is to keep temperatures within 1.5 degrees by the end of the century, above which, you know, things get a little bit hairy. But I think what's interesting for me is that at the moment we've got COP15 going on, and I don't know how many people have heard of COP15, but that's the biodiversity COP. So that's happening right now. And for me, this sort of really illustrates the point that although we're trying to push the idea that climate and ecological emergencies are fundamentally linked, which they are, in actual fact, they're not being addressed like that on a global level. And we really need to start considering these things together. So at the Wildlife Trust, we have been looking at carbon reduction, climate change for a number of years in a few different ways. And Living Lightly, which sort of really started to bring that together, started a couple of years ago, and it started to look at sort of carbon reduction in a targeted way. So it really sort of started to establish direction of travel. And I mean, this is a little screenshot from Wildlife Trust strategy that we're working on. You can see within the priorities that we have, reducing our carbon, our greenhouse gas emissions to net zero before 2030, and at the same time ensuring that the landscapes are as climate resilient as they can be. You know, they are big priorities. So with that Living Lightly work that sort of really set the scene, that coincided with some work and some funding at a national level through the Wildlife Trust. They got quite a substantial amount of funding from the People's Postcode Lottery, and some of that has been directed towards individual trusts to help with our carbon footprint, and to get some sort of consensus and coordination between all the trusts so that we can measure and benchmark against each other. So the first thing I started in December last year, and I suppose my first job priority that I was tasked with was to carry out the carbon footprint for the trust. And in order to do that, we used the greenhouse gas protocol, which is a very sort of recognized, understood way of looking at your carbon emissions. And the idea of this is to set boundaries to get an inventory of emissions that is measurable year on year. And as you can see, within the boundaries that we chose, grazing and livestock is a big part of the footprint. I mean, a huge part of the footprint. And obviously we conservation graze, for ecological reasons, to meet some of those objectives, to make sure the landscapes are as biodiverse as they can. But, you can see there that with that objective, there is then, a big sort of greenhouse gas challenge there as well. I think it's really worth pointing out that though it says carbon footprint, this is carbon equivalent. So this does include all those greenhouse gases. So, in terms of what that means, how we approach that challenge of livestock, managing land in a different way, that kind of really sets out the stall. It's Wildlife Trust, has a lot of reserves across Sussex and different workplaces. So, obviously fuel use, whether that is commuting to work or to different workplaces, that has a big part of the footprint as well. And again, we have to think of ways that we're going to address that. And I mean, water is surprisingly a small part of the footprint, but it's very important in terms of that climate resilience and sustainability to really look at that. So just wanted to put this slide in very quickly, because what this is all the trusts across the country, who have done their footprints. And I think what you can see is that we are boringly average, in fact. So, livestock is a big challenge. Grazing is a big challenge for everyone, which in some ways is brilliant, because, it means that, there is a lot to be gained from working together with other trusts on very specific carbon emission areas. So, what do we do with all this evidence and this information? Well, what we do is we come up with a carbon reduction strategy, greenhouse gas reduction strategy, and an action plan. So we have, we're very far down that approach. So we've got a draft action plan and strategy, and we've identified areas that we need to address. So that might be, around the energy use in our buildings, to say, around what we do with different land management practices, what we might do with what vehicles we use, whether we look at electric vehicles, electric hand tools. There's a whole wealth of actions that we are currently looking at. And I think it's really important to say that although we're not measuring the emissions, some of those indirect emissions, so obviously a lot of visitors visit our sites, that we are looking at what we can do within the action plan in terms of putting in EV charging points, whether we link with cycling, public transport. This picture is, for those of you who don't know, it's a newly built Rye Harbour Discovery Centre, and there's some fantastic features in there. Some really good passive solar design, some solar panels on the top. There's air source heat pumps. In terms of sort of how people get to the site, so we're looking at ways in which we address that. The carbon reduction trajectory on that slide really shows the sort of pathway. So we're looking at 15% reduction year on year, and what net zero means is that it's pretty impossible to reduce your emissions to zero, completely to zero. So there will be a point, and I think some of the other speakers will probably touch on this a little bit, in terms of what you do with those residual emissions. So this is where sort of looking in detail at our habitat carbon, the ability of our different habitats to sequester and store carbon, what that might mean in terms of any kind of offsetting approach. That's where it starts to become really important. And obviously that's a very, that's a rapidly changing area in terms of evidence and what we understand. So that's a tiny little bit in the future, not much, but it is a bit in the future. And the important thing is to reduce our emissions as much as we can. And this is just to show, example of the role of nature-based solutions. So this is Sussex Flow Initiative, which is an initiative on the Use catchment. It's a project that's been running for quite a while. And, essentially what it illustrates really well is the role that nature plays in sequestering, storing carbon, and making the landscape more resilient. So in terms of holding floodwater. And in our next webinar on Tuesday, Sam Buckland, who leads on that work, is going to go into that in some detail. And it's a really exciting project. This is just, I just wanted to highlight this because it's a newly released document from the Wildlife Trust, just in time for COP26. So this really sets out, it's called Let Nature Help, and it's worth checking out. And at the end of the webinar, there will be some links. So it's on one of those links. But it sort of looks at the role of nature-based solutions in Wildlife Trust. More of which, and in fantastic detail, Tony and Julian and Ray are going to cover. So that was a very quick canter, and I'll leave it there. Thank you.
Okay, thank you very much, Matthew. That was great. What we're going to do now is actually go straight on to our next speaker, which is Julie Middleton from the local Sussex Nature Partnership. And she's going to be talking to us about carbon storage, sequestration and flows in habitats. So Julie, thank you so much. Over to you.
Thank you, Henry. And perfect segue from Matthew's teed that up really nicely for me. So I've been working with the Nature Partnership for several years now. And one of the key areas of work that we're interested in is just how does nature contribute to thinking about carbon and climate change. So what I'd like to do today is just use a bit of what I've learned really to cover some basic principles and to cover some of the key issues that we're thinking about. And actually, Tony and Ray are then going to give you a little bit more detail about two particular types of habitats. So I'll run through very quickly the role of nature in doing two things: storage of carbon and sequestration of carbon. I'll have a little bit of information about how our different habitats perform on those roles, because that's really quite interesting when we're designing sort of projects to do this sort of stuff. I'll talk a bit about what offsetting is and some of the really key factors to understand about the challenges of using nature for offsetting, and leave you with some guiding principles at the end, which are purely my own. But just to start to say the two particular functions that habitats perform for us. First of all, they are stores of carbon. So they lock carbon into themselves, into the vegetation above the ground and into the soil below the ground. And we measure storage of carbon in habitats in terms of tons of carbon stored per hectare. But they also sequester, and sequestration is the process of sucking up the carbon dioxide from the atmosphere, taking the gas out of the atmosphere and pulling it into the habitat. And that we measure in tons of carbon dioxide equivalent per hectare per year. So that is how we talk about sequestration rate, and I'll get onto that in a second or two in terms of how different habitats perform. But the interesting thing to remember is that we could have some habitats that are fantastic stores of carbon, really important for what they currently lock in the ground right now. And yet they, as sequesterers, might actually be quite slow. And it's really important to understand when we're designing projects to sequester carbon, just which ones do that the best. All of the habitats we have really are stores of carbon, and they do that, as I've said before, in terms of locking the carbon into themselves. I've put ancient in here beside grasslands because actually the longevity of habitats is quite important in terms of how good storage, how good a store they are, and that's to do with how undisturbed they are. And if you look at this graph, and I apologize for a few graphs here, but the statistic on the right-hand side is really startling, that 94.2% of the total carbon stored in habitats in the UK is stored in the soil. And that's the big green line across the top there. That's the total carbon stored in our habitats, is that whole line across the top. And you can see there's a tiny little bit in blue at the end, and that represents the carbon that's stored in the vegetation. And if you look down the subcategories of habitats that we've got there, you can see that that's predominantly in trees. So for all of our other habitats, it's what's under the ground and what's in the soil that makes the absolute difference. And it's about keeping it there. This is just another sort of league table, and the column in the middle is the carbon stock in the soil. The column on the right is the carbon stock in the vegetation. And you can see here why woodland is the winner. It has got a a lot of carbon in its soil, but a lot of carbon in its vegetation, and that's predominantly in the woody vegetation across the top, above the ground. And when we look at others that are really good and strong performers as stores, we see bogs, grasslands, fens and swamps, and you can see the predominant amount of storage that they carry out is in the soil underneath the ground. Sequestration is a different thing, and I apologize for yet another graph, but if you see this midline down here, anything to the left of it is taking carbon out of the atmosphere, anything to the right is adding it or emitting it into the atmosphere. And again, you can see the top two here, woodland, and woodland really stands out as a habitat type that can sequester carbon really quickly from the atmosphere. And down here, Ray is going to talk about just how good salt marsh is as a sequesterer. And we've got other pretty good performers in here around orchards and some of our grassland. But it's worth flagging what bogs do. And peatland is quite a topic when we talk about habitats and carbon. But if you look at a natural bog, you can notice actually how little it does in terms of sequestration. But that's a natural bog sitting in very good condition, minding its own business, storing up its carbon, and it's sequestering a little bit year on year. But look what's happened when we modify it. When we drain it, it starts to release carbon. It flips across to being actually a problem and starts to release carbon into the atmosphere. And if you go down here and you look at what happens when we put agriculture, intensive agriculture onto deep peat, it becomes a serious issue. And it's really worth remembering that in terms of what we can do with peatland. So just another few horrible facts here, 67,000 hectares of deep peat soil in England. That's a storage of 140 million tonnes, but only 4% of it, tiny amount of it is in good condition, sitting there, just locking carbon in. And the vast majority of it is actually emitting carbon, 16 million tonnes of carbon dioxide equivalent per year. So when we talk about a nature-based solution for climate change involving peat, what we're not talking about is using peat to suck carbon out of the atmosphere. What we're talking about is fixing it to stop any more loss. And that's a really important thing to remember with peatland, that restoration projects that are carried out are to do with really minimizing that huge loss of carbon into the atmosphere, 2 to 3 million hectares in the UK, with the potential to really reduce emissions. So in terms of nature, 4 key things we need to think about. Protect the habitat stores of carbon we already have. All of those habitats I mentioned are locking up carbon. The more disturbance you make to those, the more carbon we release. That we have to work really hard to get it back again. We can restore carbon certain habitats to reduce carbon loss. We have to focus a lot more on soil, and we really have to understand a lot more about soil and how we manage it and what the impacts then are on carbon emissions. And we, of course, can create new areas of habitat to actively sequester carbon out of the atmosphere. So I don't need to tell you this because Matthew's already showed this, but this really does sum up what I've just said in terms of the power of nature to do all of those things I've talked about. And it also does talk about some of the risks and the loss of habitat that we're experiencing, which is putting all of this at jeopardy. So to flip very quickly to offsetting. Offsetting is a very topical thing. I mean, I'm sure we all know that tree planting is at the top of everyone's agendas at the moment. You also know that if you fly on a certain well-known airline to Spain, they might offer you an opportunity to pay for 6 trees, I think it is, that might cover a flight to Spain that would offset your flight. So offsetting is the deliberate practice of carrying out an activity or project to reduce or remove a greenhouse gas emission and to balance emissions, greenhouse gas emissions into the atmosphere. And I just wanted to put this diagram of a balance in because it is often very simplistically described as literally, we have CO2 emissions going into the atmosphere and they can be balanced by offsetting. And the government here has even explained it in quite simplistic language. But unfortunately, it isn't actually as simple as that. And there've been some quite startling expressions of concern around how offsetting is perceived. And the UNEP here have sort of said, look, it absolutely cannot do the job without drastic reductions in the emissions that we put into the atmosphere through our sort of status quo practices like coal-fired power stations, electric petrol vehicles, and so on. Also, using offsetting in a simplistic way could be potentially dangerous, giving the illusion that they are the fix. And much more cynically, as Greenpeace have pointed out and others, the whole concept of greenwashing is that offsetting can actually be used as something to hide behind if companies are really not doing very much at all around emission reduction, but want to tempt you and make you feel a bit better about investing in their product because they are doing a bit of offsetting. So it's just to be aware that offsetting sits in what we call a carbon management hierarchy. And this is like recycling hierarchy. You have to avoid, reduce, and replace technology that's carbon expensive. And at the very end, when you've done all of that, if there's something left over, and Matthew talked about this, that's when you use offsetting. And what we know from what I've just said is that we've got peatland projects across the UK that would be very helpful for reducing up here on the reduction part. And we have the potential to create habitat to actively remove carbon dioxide from the atmosphere. And so these nature-based solutions are an incredibly important part of a package of measures. And I think that is the real important message to understand, that it has to go alongside a huge amount of effort around avoidance and reduction. But to use nature as an offsetting solution has a lot of challenges. If you said to me, I've got a ton of carbon I need to offset, and I'd like you to create some habitat for me to offset that ton, I would have to answer all of these questions. I would say, well, how much carbon do our habitats sequester, and how fast do they do this? Can we calculate it? Can I do that with any certainty in the science? How does sequestration of carbon by a habitat change through time? And it does. It changes quite significantly in some cases between creation and maturity. What we do with it when we've got it, when we manage it, how does that impact the rate of sequestration? Where do I put it? Is there a problem if I put it in a certain place? Is that going to have an impact on an existing habitat and how it stores carbon? All sorts of questions that need to be answered. And then can we package it all up in a way that makes sense to somebody who might want to buy it? Now, very quickly, the evidence base is very much emerging. So the science is running to catch up, and Ray's going to talk to you, I think, a bit about that too. But what we can say is that for two habitats, woodland and peatland, we can do things with quite a lot of certainty and quite a strong evidence base. We know what these habitats tend to do, and we can develop projects based on that. Much, much less certainty around marine and coastal habitats, other terrestrial habitats, and soil. Tony's going to tell you about woodlands do through time, and that's also very important to understand. But finally, just to say that, I mean, the government are really starting to put their shoulder into some of this stuff to really help us develop projects using nature that are fit for purpose in terms of offsetting. And they have 7 factors that they've identified to do with how ready are we? Do we know how to create these habitats? Do we know how to measure their effectiveness? How fast do these things actually work? Are they permanent? I mean, any offsetting project has to lock that carbon up in there forever for it to be helpful. What are the other benefits it needs to deliver, including for biodiversity? Can we be confident? Can we measure their impact? What are the risks and barriers, and what are the costs? I mean, for example, we know in the UK that offsetting projects here will cost more per ton of carbon than, say, something in the tropics. It's just the way it is. And this is my second last slide. So just very quickly, they've put together a red, amber, green analysis of our different types of offsetting project approaches. But if you take woodland here, third row down, it's a removal project. And look, it's getting lots of green lights along those 7 factors around costs, readiness, and around longevity and on confidence. But it's worth looking at the red in there around speed of impact. Nature can do this job, but it takes time. And if we look at some of the other habitats down here, the grey just means we don't have the data. And the orange is saying, well, we're almost there, but not quite. And red is clearly a problem. So you can see what I mean. It's not straightforward, but the good thing is that we are making progress. So finally, some key principles just to say, and these have sort of come off the top of my head and when I've been thinking about this stuff. Absolutely fundamentally, we need to protect the carbon stores that we have. We need to do far, far more as a society to protect the habitats that we have already from all sorts of pressures, from development right through to land use change. We need to be vigilant as individuals and organisations, and as Matthew explained, there's a process to go through as an organisation where you look at what you need to avoid, reduce and replace way before you offset. And offsetting projects are an important part of an overall approach, but they are complicated, and it's really important to understand the complexity and to really actually, before you invest in one yourself, ask yourself, are these actually going to do what it says on the tin? Are they going to store the amount of carbon they say they are? But we do need to embrace them. This is not about being negative. This is about saying, do you know, we've got a biodiversity emergency and a climate emergency, and nature-based solutions and nature-based offsets are absolutely a sort of twin track approach to solving both of these at the same time. And as we go forward to COP, one thing I would say, and I hope this is true, that we can expect more from our leaders in this area. We need more commitment to the protection of our habitats. We need more investment, and we need more innovation in just how to unlock the potential of what nature can do for us.
Well, thank you so much, Julie. That was information packed and a real wow. That was really,
sorry, bit of a speed.
But I mean, it's a real skill to explain something so complex so well. So thank you so much for sharing all that knowledge with us. And we've heard about how important peat is, but of course in Sussex we don't have any major peat to be doing amazing stuff with. So the question is, what about the trees then? So we're going to pass on to our next speaker, Dr. Tony Whitbread, and he's going to explain to us what about trees.
Thanks very much, Henry. Thanks very much, everyone, for listening in. So yeah, so it's all about trees then. It's you've seen the evidence that Julie's put together there, and it's clear that tree planting or trees, forest creation, they're a large part of the answer. So I want to look at that in a little bit more detail. Give me a couple of minutes to actually share my screen. I can find it. There we go. If you can all see that. Okay, so will tree planting save us? You know, it's very much a thing of the time that we need to plant more trees. Many people are saying it. You know, you can plant more trees, and therefore that's going to lock up carbon. So it seems a very attractive thing, and it's actually true. If you look at our countryside, there should be plenty of opportunity. You know, there should be a contribution that nature can make to draw carbon out of the atmosphere and therefore fight climate change. And actually, when you look at Britain, we're only 13% wooded, which is way lower than most of Europe. I think the average for Europe is well over 30%. So it should be reasonable to double our woodland cover without too much trouble. It would still be one of the least well-wooded countries in Europe. I think it's only Ireland that has a lower woodland cover than we do. So there's clearly opportunity there. We should be able to actually increase our woodland cover a lot. So maybe tree planting is important. And here's a few sums here, which I just managed to unearth. Apparently, in the whole of the southeast of England, the annual growth of timber, the annual growth of trees, accounts for about 1 million tonnes. About 1 million tonnes of growth is put on every year in the southeast of England. So assuming that's dry weight, about half of the dry weight of a growing tree is carbon. So that's 500,000 tonnes of carbon. We have to be careful of units here, because 1 tonne of carbon makes about 3.67 tonnes of carbon dioxide. It works the other way around as well. So if you're actually sequestering 1 tonne of carbon, you're actually locking up 3.67 tonnes of carbon dioxide. So you do the sums this way around, 500,000 tonnes of carbon, that's actually sequestering nearly 2 million tonnes of carbon dioxide. Nearly 2 million tonnes of carbon dioxide is being sequestered every year by tree growth in the southeast of England. Well, that's interesting, isn't it? That's great. There's the opportunity, therefore, to put that into uses which store it long term. So buildings, for example, furniture, making things out of wood. So you harvest the timber and you can lock it up for a long time by putting it into things that last. Now, this actually has a double whammy, a double effect, because first of all, you're locking that carbon up for a long time. But the other effect you're doing is you're probably replacing something else which has a much bigger carbon footprint. So in buildings, if you use more timber, you may be using less concrete and steel. Concrete and steel are incredibly, they produce an awful lot of carbon dioxide. So you're actually reducing that as well. And I'm not going to talk much about it today but let's not forget, it's not just about carbon. Woods are really important for all sorts of other things. Soil, water, landscape, heritage, biodiversity. So there's all of those things as well. So woods are very important. So there is a good opportunity to lock up at least some of our emissions and long term, year after year. You probably cover the tone of my voice. There is a big but. There is a but to all of this, and we need to think about what this but is. Let's go back to a graph that I hope a lot of us know now. This is the on the left-hand side here. You can see if you can see my pointer, that's where we are. This is the emissions of carbon dioxide per year. We're up here, about 43 billion tonnes of carbon dioxide per year. And this is what we're going to have to do to actually get that down to zero. Our emissions are going to have to fall off a cliff to stand a chance of actually keeping our temperature below 1.5 degrees above pre-industrial levels. This is an enormous change to society, an enormous change. So there's a big change going to have to happen in a very short space of time. We're talking about a decade or so to make big changes to these emissions. We're still going up. The carbon emissions are still going up year on year. That needs to change around very quickly. We look at this next graph, and it's probably familiar to most people that are looking at this. This is the concentration of carbon dioxide in the atmosphere, going up from around 1960, about 320, now it's nearly 420 parts per million. Industrially, it was below 280 parts per million. This is all surplus carbon dioxide or extra carbon dioxide in the atmosphere already, which will last for thousands of years, perhaps. So we've got far too much carbon dioxide in the atmosphere. We've probably got more carbon dioxide in the atmosphere than at any time in previous human history, probably for over 1 million years. This is exceptional stuff. Too much carbon dioxide in the atmosphere. We have to draw some of that out of the atmosphere. It's not just about getting down to zero. We're going to have to remove some of this carbon dioxide. And the idea that you can just do everything by planting a tree. You know, your climate plan, it's okay, we can just carry on with business as usual as long as we plant the occasional tree and everything will be fine. But I think Julie's already made this very clear, and it still comes up time and time again. No, we can't continue business as usual. We are going to have to stop emitting carbon dioxide. Pure and simple. Net zero, yes, but that's right at the bottom of the decision tree. We're going to have to stop producing carbon dioxide, and we need nature-based solutions as well. It's not either or. So we really have to actually not give the idea that, okay, business as usual is fine, it's fine as long as we just plant a few trees, then we can carry on as normal. I've seen this many times over, people saying, yes, well, actually, if we look at all the trees we can plant, surely that'll be fine, and then we can carry on living our lives as before. No, that's not the case. And let's be clear about this as well. Enormous ecological damage was done in the 20th century by tree planting. If we forget our history, then we're condemned to repeat it. I sometimes fear that we are in this place at the moment. Enormous ecological damage was done. The Low Country in Scotland, for example, was planted up with vast numbers of trees. In the process, of course, the peat was drained to make them grow, so therefore the peat oxidized. Therefore, there was quite a large net production of carbon dioxide. That's just one example, but it happened all over the country. And even down here in Sussex, some of our most important habitats were actually lost to tree planting. Think of heathland. Over about 100 years, we lost 80% of our heathland. And nearly half of that was down to tree planting, not to agriculture. And many of our heathland species would have disappeared if that had carried on. So it's really quite critical. And we need to bear this in mind. We can't just destroy one habitat by planting up with trees. It's my opinion, but I think actually more than half, planting trees was second only to agriculture and intensification in terms of the amount of damage that was done to habitats. So we really have to bear this in mind. Also bear in mind that 75% of the carbon in woodlands is actually in the soil. You look at a woodland and you think, great, there's loads and loads of trees there, loads and loads of standing crop. But actually, 3 times as much carbon is in the soil than is actually in what you're looking at. Also, old growth woodlands continue to absorb carbon long term. Yes, they slow down, but actually, and the science is slightly indecisive on this, but it's better than most science, yes, they continue to lock up carbon long term. And structurally complex woods, woods with layers of vegetation, lots of deadwood and so on, complex woods store more above ground carbon. That's important. And I think the message that's coming out of there is that actually looking after what we've got is vitally important. This is what Julie has already said. So it's not just about planting more trees. It's not just about getting more trees. It's actually about looking after what we've got. And this is important as well, because I have heard people say, well, you look at a wood like that, that's all very well, but it's not sequestering carbon that quickly. What you need to do is cut it all down and plant fast-growing things like eucalyptus. No, that's not what you need to do. Looking after what's there is most important, because most of what you're looking at, most of the carbon you're looking at is in the soil. The other side of that is that actually you can lose a lot of that carbon by disturbance. So forestry activities, unsympathetic forestry activities, can actually cause so much disturbance that any amount of tree planting will take decades to make up the loss that's caused by that disturbance. It actually is a picture of quite good practice. You look at the tyres on this, they're low impact, there doesn't seem to be much soil disturbance going on there, but actually it is a risk. And also bear in mind that some of the faster growing trees like the conifers have shallow rooted, they're shallow rooted. So they're very easily disturbed by forestry operation. So you can lose all the carbon you thought you had sequestered. Newly planted trees, yeah, planting lots of trees, great. They take a while to ramp up their sequestration. They can take up to 10 years. Well, we haven't really got more than 10 years to play around with this. So you can't rely on tree planting doing everything from year one. It takes 10 years to ramp up. And carbon uptake rates increase with time. Therefore, they gradually shallow off and slow down as trees reach maturity. Peak sequestration can be about 100 years into the future. Science varies on this, but it can be about 100, that long into the future. Okay. Back of a fag packet calculation. I worked this out and just thought, so let's have a look at a few sums. Okay, so given really good soil, you can get about a hectare of trees sequests about 10 tonnes per annum. Very good. Bearing in mind what I've just said, 43 billion tonnes produced per year by our activities. Okay, so that's a lot, but therefore do the sums. That means we need to plant up 4.3 billion hectares of good agricultural land to get that sequestration. That's a big number. I don't know what it looks like. I Googled it and looked for a comparison, and that's about twice the size of the USA and Canada combined. Well, that's a big area. It's also about the same as the total amount of productive agriculture on Earth. So actually, you're at a stage now where we want business as usual and not eat because we've used up all the planting up potential, or are we actually going to do something else? So the idea that we can just balance all our emissions by planting is cloud cuckoo land. So what is the opportunity for tree planting? Well, there is some, of course, and there's been an example we looked at in Lewis District. If you take out areas that it's wise not to plant, like grade 1 to agricultural land, urban areas, of course, but there are some key open habitats as well. And also, of course, there are areas that are already planted with trees. So Lewis is already quite well wooded. That takes out about 52% of the area. That only leaves about 48% available for planting, and a lot of that is in private land, obviously. There is some opportunity, but it's limited and we shouldn't overstretch it. And actually, that's still a big target. That will make a major landscape change by planting up that amount of land. I think Julie's already mentioned the role of woodland management. And again, there are two columns here. One on the left is the amount of tonnes per hectare of carbon dioxide locked up. So that's the amount stored in a habitat. The column on the right is the rate of sequestration. So you can look at there and you can look at the two extremes. With unmanaged forest, you could think old growth forest, there's a lot of carbon stored up in that habitat. But actually the rate that it's being locked up is quite low because it's reached a kind of plateau. The other end of the extreme, you've got something like biomass production, which is growing very fast, but actually the amount that's locked up is quite small. So you've got a low store, but a high turnover. It's more or less cycling the carbon dioxide. And in between, you've got near to nature forestry and so on. So the type of management actually does influence these figures to quite some extent. Okay, I want to finish now by just saying, let's not just talk about tree planting. I mean, we're always talking about planting, and yet that should not be the default option. We need to talk about natural regeneration first. Trees can plant themselves in one way or another. They don't need people coming along and planting them. But look at the benefits of natural regeneration. It creates species diversity. You're actually regenerating what's there already, creates genetic diversity. Now, this is important because actually, if you plant something, you get what you plant. But if you allow for natural regeneration, then you're looking at actually selective pressure. You're looking at the way evolution works. You're getting a range of species and a range of genetics which become suitable for the site. That drives ecosystem diversity, and that drives greater resilience. Also, natural regeneration can lock up carbon faster and with less disturbance than tree planting. So let's actually have natural regeneration as the default setting, not tree planting. And let's look at some of the examples. Here's a case just down the road, the Net Rewilding project, where 15 years, that's the difference between these two photographs, and all of those trees were not planted. They were, well, not by humans. A lot were planted by jays, squirrels, mice, windbone, and so on. One jay can plant 4,000 acorns in a year. It's thought that the total population of jays plant about 4 or 5 billion trees. Okay, just to finish now, woodland creation, or rather forest creation, is of great value. But it's greater value than just as a carbon calculation. There's more to it than just as a standing crop of carbon. I also like to think about forest rather than woodland. Woodland is the wooded part of a forest. Forest is a much more diverse ecosystem, including all the open and closed habitats and so on. So a forest is important, but it's more than just as a carbon calculator. I want to make the point that we have failed to prevent climate change. Climate change should be past tense. We are now living in the future that we've been warned about. So we need to think about resilience. A much wider role for forests in ecosystem restoration, regeneration, resilience, alongside a spectrum of other nature-based solutions. So the forests are not just a standing crop of carbon to make our to offset what we're doing at the moment. No, they're part of a much bigger resilience package. And we need to build environmental resilience in what is now definitely a changing world. So forests are much more important than just their carbon, important than they are for that. We need to recognise their ability to build resilience as part of other nature-based solutions as well. Thank you.
Thank you very much, Tony. I'm going to use my host's prerogative and just squeeze in one question, because we have a really good question from Tony Cook. And I'll just, it's going to have to be quite a quick answer, I'm afraid, Tony. But other Tony says, I volunteer for SWT amongst others, and our habitat work for heathlands in particular requires removal of some trees, particularly silver birch. How effective or otherwise are these trees at sequestration? Are we doing more harm than good? Great question.
Yeah. It's a good question, and these sorts of things often come up. And I think we enter into problems when we think too much just about carbon. Because actually, then you're forced down a kind of direction which is actually taking away the diversity of nature. And now heathland is as much a natural habitat as anything else. And so actually there are natural processes by which heathland is created. And we're basically replacing them by our management. So yes, we're reducing the amount of standing crop of carbon. If we're doing it sensitively, then we're not interacting with soil, so the soil carbon is still there. So yes, this is why I think it's very dangerous to get focused on just one habitat and saying it's all about carbon, we must lock up our carbon, and actually not worry about biodiversity destruction. No, it's much bigger than that. And this is why I think it's important not to get focused just on nature as a cure to our carbon problems. It's a cure for all sorts of things. You need all of its services, not just as a standing crop of carbon.
Okay, Tony, thank you very much for that answer. And Tony Cook, thank you very much for the question. So we're now going to move on to our next speaker. Thank you, Tony, for bringing the whole issue around trees and carbon to life for us. And we're now going to pass on to Dr. Raymond Ward from the University of Brighton who's a marine scientist who's going to talk to us about marine and coastal carbon storage. So Ray, thank you very much, and over to you.
Okay, I'm hopefully sharing my screen. Can you see that okay? Henry?
No, I can only just see you. You haven't shared your screen.
Annoying. I thought I pressed share screen. I'm more of a an expert on Teams. Here we are. Okay, how about now?
Yeah, that looks like it's working. It's just, yep, absolutely. Okay. Bingo. Thank you.
Brilliant. Okay, excellent. Yeah, so I'm moving on from the land out into my natural environment. As you can see, I spend most of my time underwater, even right now. and I'm going to be focusing on coastal marine carbon flows. It's kind of interesting, as there was some discussion there about there's been this big push in the UK. Now, I actually started looking at this quite a long time ago, over a decade ago, and at the time no one seemed particularly interested in the UK. So it's only recently that we've started to have a bit of a push to take into account coastal and marine carbon flows here in the United Kingdom, which is good because it means that I've managed to actually bring some of my research a bit closer to home now. So when we're talking about carbon, I guess this we kind of briefly covered this. We think we can kind of put it into a series of different pools. So I've got there the atmospheric pool. That's the thing that we've been slowly filling up over the last sort of couple of 100 years, burning fossil fuels and the such like. Let's put a little bit more carbon up there. And then we've got oceanic pool. That's sort of 2/3 of the surface of our planet. We've got a geologic pool, so that's when we're talking about our rocks. We've got a soil pool, so that's the pedologic part. That's there, as we mentioned before, that's quite an important part of our carbon sort of sequestration and storage. And our biotic pool, well, I'm part of the biotic pool. The picture of the kelp behind me is part of the biotic pool. So anything that's alive at the moment, that's what we consider to be our biotic pool. And you can see there's sort of an interplay between all of them. There's release of carbon from the oceans and sequestration of carbon to the oceans from the atmosphere. Geologic pool, so if you've got volcanic activity, that kind of puts a bit more up into the atmosphere, and it can be put into the rocks as well. Atmosphere to soils, particularly if you've got breakdown of kind of organic material in your soils, that goes up into the atmosphere and then back down again. And then biotic pool, I'm sort of slowly building up more and more carbon in my body as I get a little bit older, a little bit bigger. So our trees do that, and also all of the plants that kind of grow in our sort of coastal systems. And you can see there, the big chunk of that carbon is our oceanic pool, and oceanic and geologic pools are fairly sort of stable. And you can see there's a huge amount, 38,000 petagrams stored in our oceans. Okay, now that's where the bulk of our carbon kind of goes from the atmosphere, and that's an important part, because then we start to think about climate change mitigation, trying to sort of draw some of that carbon out of the atmosphere and storing it away. Okay. Now, really importantly, 55% of our atmospheric carbon is actually taken up by our oceans. Okay, so the bulk of what we're putting up there at the moment goes into our oceans and is stored away. Okay, now even more importantly, 50 to 71% is stored in our, I like to term it as vegetated blue carbon systems. Okay, so blue carbon, you can consider that as sort of a subsection of green carbon, and it's what's kind of stored in our vegetated oceanic or coastal systems. Okay, and I've got some pictures in there. So I've got salt marsh up there, sort of up in the middle here. I've got macro algae, sort of seaweeds, kelps particularly, up here on the top right hand side. Some seagrasses, so these are sort of our marine angiosperms, are really good for locking away carbon. And then just in the bottom there, the only one that we don't have in Sussex is mangrove ecosystems. They're excellent. You get those, they have a sort of pan-tropical distribution. So if you look in the tropics, that's where you've got them. Okay. And even more important to that, we're talking about a huge amount of that carbon that's locked away. It's locked away in a very, very small area. That's less than 0.5% of the seabed is covered by our sort of blue carbon vegetated ecosystems. Okay, so you've got a huge amount of carbon stored in a very small area. And that is important because it means that they provide a really important ecosystem service, but also that they're obviously under threat by being such a small area. You start to degrade that area, you've lost that ecosystem service, that carbon storage and sequestration. Okay. Now let's put this into a bit of a context. I've got there some sort of some principal ecosystems for carbon storage. I've got there seagrasses. So we've got seagrasses here in Sussex, Zostera rupea, sort of eelgrass, and widgeon grass. Okay, we've got salt marshes, obviously. We've got here in the Ada, the Ouse, etc. Here in Sussex, estuarine mangroves and oceanic mangroves we haven't got, and we haven't got tropical forests, but tropical forests are not too different from some of our other forests. And you can see that actually seagrasses and salt marshes store a huge amount of carbon. And if you have a look at that figure, you can see that the bulk of that carbon is actually stored in the soils. Now, when you look at that compared to sort of tropical forests, and you could look the same for sort of boreal or temperate forests, okay, you can see that what's stored in the soils is substantially more in our seagrasses and salt marshes. The reason for that is they are really thick soils. I mean, I was just coring recently down in the Ada, and we got 3.2 meters of organic soil there in that salt marsh. Okay, so really quite a deep carbon store, and that is constantly being replenished. Okay, it's locked away for a very long time period. Now, the difference between tropical forests or boreal forests or even grasslands is you get death of the plants, they kind of break down, they go into the soil, but there's also a lot of bacterial activity. So you get large scale releases of CH4 and CO2. Okay, so a lot of that is actually re-released out. Now, due to the fact that you've got our seagrasses and our salt marshes are in marine environments, in saline conditions with limited oxygen, that means that there's reduced microbial activity. Therefore, we've got much less of that cycling, sequestration, and then losses. We got more sequestration and storage in those areas. Okay, so that's quite important, because what that means is that they are locking away this carbon for millennia. Okay, now if I put that into, we'll move away from sort of the soils now, and we start to look above ground biomass. Now, above ground biomass in salt marshes, anyone who's been to a salt marsh, you know the vegetation is not too tall. It's kind of low, herbaceous, grassy type vegetation. So we won't put that into the comparison, but when we're thinking about biomass, we can start to think about our macroalgae, particularly our kelp. Okay, so I'll put there just figures of above ground biomass there, and you can see that sort of tons per hectare, we've got about 6.65 tons per hectare in kelp. Okay, so that's our invisible macroalgae, the stuff that you don't usually see, and that's actually, you know, that's kind of in the a similar but lower ballpark to sort of broadleaf forests and coniferous forests, and much more than our heathlands. Okay, and it also covers quite a substantial area. So I'll put there now just over 8,000 kilometers squared in the UK. Okay, now one of the negatives to all of these habitats, and I'll come on to that in a second. Sorry, one of the positives to those habitats is that those rates of sequestration, I put there, tons of carbon per hectare per year, is actually really high. Okay, so now I've put there salt marsh and seagrasses 1.2 to 1.5. That's from some of my data that I've collected from here in the UK, and that kind of puts us in the ballpark as similar to other salt marshes in kind of other global regions. Seagrass is a little bit lower, so rates of sequestration about half of what you find in salt marshes, and that's actually from seagrasses. That's data that I've collected from seagrasses here in Sussex. Now, kelp, you can see along there. Now, what's important for that? It looks very, very high. Okay, now kelp grows very, very quickly. All our coastal ecosystems are highly productive due to the fact that there's a large range of nutrients that are inputted there. Okay, so they can the plants can grow very quickly. Kelp grows very, very quickly. Now, what I've put there is that's net primary production for the kelp. Okay, so it grows very, very quickly, but what's stored there is not stored in the sediments. Kelp and macroalgae don't have soils. Okay, they have holdfasts, so a lot of that will actually be broken down. Now, this is the difference between our macroalgal habitats and our salt marsh and our seagrasses. Terrestrial habitats really well studied for about 50-60 years. Okay, salt marshes, seagrasses, and the other one's mangroves that we don't have here. Okay, they've been studied for about 10, 15 years, maybe sort of 20, from this kind of ecosystem service perspective of carbon sequestration and storage. But we still know very little. In fact, with seagrasses, we don't even know what the full coverage is, even here in the UK. Okay, we've got quite a large ballpark figure. Now, kelp, we don't really know how much of the carbon that's sequestered into the biomass is actually stored. How much of it is broken down, lost, and re-released into the atmosphere? How much is actually stored in the offshore sediments? Okay, and that's something that we're working on at present for our local kind of Sussex kelp ecosystem. Okay. Now, what's important of those kind of marine blue carbon systems is that you've got a wide range of sources of blue carbon. Okay. Now, seagrasses, they will grow. You've got the above ground biomass, you've got the below ground biomass. Because they're subjected to sort of high, well, a bit of wave activity and tidal activity, they have a really, really dense root network, much more dense than most other angiosperms. Okay, so flowering plants. That means that there's a lot of carbon locked up in their biomass below the surface. Okay. Then you've got that that's locked up in the surface biomass, and then you've got that that's locked up in the sediment. And that can be exported to other ecosystems, maybe the salt marshes, okay, maybe into sort of offshore sediments, okay. So that's kind of our biomass kind of pool and our pool and our pedologic soil pool, okay. Then we start to think about, okay, where else does this carbon come from? Well, in actual fact, in our coastal systems, we've got loads of carbon coming off the land. I've done quite a lot of studies on sources of carbon using various signatures of carbon and nitrogen isotopes. Okay, and actually a large proportion of this carbon that's locked away in those, particularly in salt marshes and seagrasses, actually comes from the land. It's either through soil runoff or it's through biomass coming off the land. So you get that runoff perhaps from agriculture, perhaps from forestry, adjacent, goes into the rivers and gets exported into our nearshore coastal zones. Okay, and locked away. Okay, so that's really important. It can be locked away, and again, like I said, that can be for millennia. Okay. Then you've got the large-scale production of like filamentous green algae. If you walk around a salt marsh, you see this all over it. Okay. Now, what if that's just left? It will get broken down fairly quickly and be released back into the atmosphere. However, you start to get sediment building up on top of it, and you start to cover that with saline water. You decrease microbial activity, you decrease the breakdown, and you lock it away again in the sediments. So you've got another source of that carbon. Okay. Then you've got your macroalgae. It could be the kelp, it could be your rhodophytes, your chlorophytes. Okay, so it could be a range of different macroalgae, seaweeds. Okay, and as soon as they break down, some of that will be exported to the offshore zone. Some of that will be exported and stored in the sediments. Okay, so that's kind of another important source of your carbon. Could be coralline red algae. Okay, so that's locked away actually in calcium carbonate. Okay, which anyone who does any diving around here, you see that there can be some coralline red algae that locks it away. Okay, and then it's sort of in situ production in the salt marshes as well. Okay, so I said they're highly productive ecosystems. Could be from Phragmites. Okay, common reed. Okay, that grows really, really quickly, breaks down fairly over the year, and then that can be stored in your salt marsh and your seagrass sediments. Okay, now the current situation is 50% of UK salt marsh has been lost. Okay, and we're currently losing 100 hectares per year. Yeah, and you can see there 57% of that is in an unfavorable condition. Okay, not good. 90% of UK seagrasses have been lost. Half of that has been lost in the last 30 years. Now then we're talking about, hang on, it's providing this really good ecosystem service, but in actual fact, we're starting to lose that. We're starting to lose that carbon that's been locked away. Okay, so when I say for millennia, it's for millennia if you look after it appropriately, you manage it appropriately, you conserve it, you protect it. Okay, and almost all the extensive kelp in southeast England has been lost in the last 40 years. A lot of you will probably know about the HELPAC kelp or Sussex Kelp Restoration Project. That's kind of looking at addressing that issue. Okay, causes a loss for salt marshes, sea level rise, coastal squeeze, environmental pollution, direct conversion of the salt marshes, perhaps to agricultural land. For seagrasses, they can be lost. They were lost through wasting disease, environmental pollution, boat activity, whether it was anchoring or through prop damage, eutrophication, decreases in light availability. Okay, all of those are having a knock-on effect, particularly if you think about that kind of organic waste that you can get deposited in those ecosystems. And then kelp, trawling, dredging, decreasing light availability and climate change can all have an impact on those kelp systems. Okay, I'm going to finish on a positive note, and this is my last slide. Government are pushing for carbon net zero. That means that these questions of conserving these really important marine and coastal systems are starting to come about. I have long conversations with the Environment Agency, Natural England, and other groups that are really trying to push, and they're taking this seriously now. Okay, a lot of nature-based solutions. Okay, how can we naturally protect our coastlines? How can we decrease flooding in certain areas, particularly sort of salt marshes provide another ecosystem service by absorbing floodwater, okay, or decreasing wave activity. Same with seagrasses, same with kelp, okay? So those nature-based solutions can also help us from a carbon net zero perspective, okay? There's a big push from government at present. So hopefully this will actually translate into some positive initiatives from government. And that's it. Thanks for listening. And I suspect Henry will probably take over now and kind of deal with any questions.
Well, Ray, thank you so much for that. That was just full of really fantastic information. And I'm sure everybody here has learned a great deal about a topic that it's really hard to find out this sort of information. So thank you very much. I'm actually going to start off with a on-the-spot question for each of the panelists. If we were to do one thing in Sussex, so I want an answer for at sea and an answer from on land, what would be the best thing we can do for our habitats and carbon? So Ray, should we start with you?
I mean, I've got kelp in the background, and that is important, but I would say probably we really need to do something about our seagrasses and our salt marshes to a lesser extent. The seagrasses are in such a dire state. People tend not to think about them or even know about them a lot of the times. And they're really not in a good state, and they provide such a broad range of ecosystem services. You wouldn't just be talking about locking away a huge amount of carbon. You'd be talking about improving the juvenile habitat for fish. You'd be talking about pollution control. You'd be talking about wave dampening, flood protection. You know, I think that would be a no-brainer, really, from my perspective.
Okay, thank you so much. Julie, how about you?
I'm not an expert in any particular habitats, but I think from a decision-making process or perspective, just understanding what all our habitats do for us in terms of climate change and resilience and factoring that into decision-making. So, you know, we lose habitats to various land use decisions all the time. And I'm not convinced that, for example, carbon impact of loss of a piece of woodland or a piece of ancient grassland is taken into consideration in those, for example, in planning. So I just think it's about understanding everything that these habitats do for us from a climate perspective and factoring that holistic thought process into decision making. And it's not because we don't know what they do. We do. It's just about making sure that that's fed into decision making processes.
Okay, thank you, Julie. Tony.
Well, I'll give you the answer that you probably don't want first, and that is very simple. Stop burning fossil fuel. You know, that comes first. The rest of the stuff won't mean a thing. You know, it will completely swamp anything else we do. Getting away from that, you know, what would I do? I would actually change the priority in people's mind. Think natural regeneration first. Think about diversity of habitats first. Think about tree planting. There are plenty of places to do tree planting, but think of it last, not first. Don't reach for the shovel to plant some trees first. Think about how nature would have done it and help nature.
Okay, thank you very much. I'm going to go to a question which came in after your talk, Tony, from Malcolm Turner. Unmanaged woods around Bexhill have self-sown trees growing close together, competing for light and very high something base, and hence less foliage. If fewer trees were grown further apart on the same site with greater foliage in the greater light, would this sequester more carbon?
I think that's unlikely. So there is a process when woodlands get going, you always have a thicket stage where things are very, very dense. And then you go through a process of self-thinning. So you end up with fewer trees anyway. And those trees that die, of course, fall down and they go into the soil. And it's all about getting stuff into the soil. So you have to think about this as a longer term cycle. Woodlands do go through this dense thicket stage, and then they break through that, and you end up with fewer larger trees. But it's actually how you get stuff into the soil, and those trees that are dying are going into the soil.
Okay. Thank you, Tony. Anonymous attendee has asked the question, do we have metrics of fishing effort decrease and catch increase from a unit of seagrass or kelp re-establishment? So Ray, I think that's a question for you. There's been a lot of profile in the press about the carbon impact of trawling. Can you elaborate a bit more on that?
Sorry, what was the question again?
Well, the question covers all fishing efforts and catch increase from a unit of seagrass or kelp established, but I'm going to just simplify it and just, can you tell us a bit more about the carbon release because of trawling?
From kelp or seagrass? I mean, seagrass is slightly less. I think we'd probably go for kelp, but I mean, what we've I think you can probably see on or probably saw on my talk. I'm just going to open it again, so I'll get the numbers. Let's see. We've got 3.4 tons of carbon per hectare per year rates of sequestration. We've got 6.65 tons per hectare, and can you remember what the extent of the kelp was in Sussex? I think you probably know that a bit better than I do. Actually,
170,000. No, sorry,
170 kilometers.
170
kilometers squared. I think that's what I had in my head, but I thought you probably remember it better now. So basically, you got times that times my hectares by 100, and that's how much carbon's been lost, which is a lot.
Okay, well, thank you very much. We've now got to nearly 8:40, so I have to really sadly close the session. I don't want to, it's so interesting, and I'd love us to be able to answer more questions, but a really huge thank you to our speakers. So Matthew, Julie, Tony and Ray for sharing your work and your insights, and thank you for everybody who has attended and for staying a bit longer than expected. And do join us next Tuesday where we've got the third of this series, where we're going to be looking at nature-based solutions happening in Sussex and talking in a bit more detail about them.